Okay, so Syed and everyone, thank you for your patience, guys. So today, what we are going to learn and what till now whatever we have completed. Okay, Syed, just allow me 10 to 15 minutes. I'm just going to describe them. What are the things I'm going to be cover on this? Okay. Hello. Yeah. Yeah. No, today I will not give that much more time because due to the health issue, share what is that netting and other things, whatever the time depend upon the time permit. Okay. No, I we are already started from from the 1st of July. We are having one English session. If you want to continue with the English session, till now there is only basics. Okay, like course content, course introduction, 48 lab setup, basic with GUI and CLI, IPv4 static default routing. Yesterday only we completed. Zone implementation yesterday only we completed. IPv4 RIP implementation and GUI and the T suite yesterday only we completed. Today we will be continue with the net. Okay. I'm really sorry, guys. I do not have any recording. Yesterday was recorded, but due to this, lack of space, I will share you. Don't worry. If you are fine, I will give you some, specific time to be covered. First, I will cover whatever that till now I have covered. Okay, especially I will cover for you. Then we will be continue together. Fine. No need to worry. Okay. Yeah. Thank you. And yeah. So how we are going to be, lab setup and other things. So yeah, we are using EVNG. Okay, under the EVNG, uh, by using this IP, I will be continue with this one. Okay, 75.2028. So this kind of our lab setup will be okay for upcoming every setup. Okay, like OSI or sorry, I OSPF, RIP, BGP, everything is there. But this batch is specific, especially designed for Mr. Said, who came India from UK. Okay, from London to learn this FortiGate only. Okay, so especially I designed this batch for as per his requirement. But if I tell you guys, if you give me some time, like 40 to 45 days, here only you are able to see RIP and RIP and static route, right? I will cover here BGP also. I will cover here ISIS also. I will cover here OSPF also. So best in CUI mode and GUI mode. Okay, clear, guys? One thing. Second thing, what are the things we're going to cover in these courses, especially? Like these are the things netting and let me still people are going to trying to join. Admit all. Okay, so these are the things. Okay, like user group authentication, site to site VPN, IPv4 site VPN, and IKE certificate authentication VPN with, because you don't consider, like suppose you are using that 40 client for FortiGate, but you can't believe, like you can't hope like other site also there is an FortiGate only. You will get a chance to work with the multi vendor, right? Like Cisco, ASA, or Palo Alto, or some other product you may get, right? So for that kind of lab also we will cover here. IPsec tunnel with a multi vendor. So let's suppose there is your branch, this is your branch with running with the FortiGate. Okay, but UK you are having one router only, but in USA branch you are having only this Palo Alto, sorry, Cisco SA, and Juniper. In some branch like Australia you are having a Juniper, New Zealand you are having a Palo Alto, right? So this kind of setup we will do, and we will configure this. Multiple vendors will configure with the FortiGate. How the FortiGate will establish IPsec tunnel with the different vendors. Okay, not only this, there is a multiple things to learn. Okay. Okay, after that, what we are having: transparent firewall, virtual vwire, high availability, server load balancing. Okay, SLB, admin profile, virtual routing redundancy like VRRP, ADVPN, 40 dial-up VPN, secure socket SSL VPN, software defined wide area SD-WAN also we're going to cover, FSSO, like suppose you are a user and you are using your AD credential to log in the machine, to access your Outlook, to access your emails and multiple things, right? In the same way, FSSO is a service which is allowing us in the FortiGate to use your AD credential to access each and every things which is organized by your, managed by your organization. Okay. So FSSO, VDOMs, link aggregation, link redundant interface, central management like 40 analyzer. 40 analyzer. Anyone knows about the 40 analyzer? If no, I will teach you on this 40 analyzer also. 40 manager also we are going to teach. Okay, parallel path processing also we are going to teach. This is especially designed for Mr. Said, who is my existing student. So after that, what is actually course content? Okay, this is for Said, but so course content the real concept which will take around 45 to 50 days to cover. Okay, course content, course introduction, lab setup, okay, RIP, T-suit, OSPF, ISIS, BGP, T-suit, and RIP, OSPF in IPv6. Okay, not only the IP version 4. We will cover in IP version 4 along with IP version 6 also. Not only the GUI mode, we will cover all the topic in the CLI mode also. Okay, and after that, link monitoring. Okay, after BGP there we are having a link monitoring, user authentication, user group authentication, site to site VPN, this with the multiple vendors. Okay, and we are having site after site to site VPN, transparent firewall, virtual wire, high availability server load balancing, and these are the things. Okay, if you give me guys your 45 to 50 days, I will make you master in the 40 gate firewall. Clear guys? Anyone, any question? Great. So, so today we are going to discuss about the net, right? Said, now it's your turn. Said, yes, yes, yeah. Said, so I believe, please don't mind for today's class, okay? This is for our upcoming. This student will be in our upcoming batches, so they just wanted to know what are the things we are going to cover, okay? So, in Hindi batch or English batch, they will be join us, okay? So you we don't get disturbance from tomorrow, okay? Yeah. So, so today we will discuss about the netting, okay? So anyone knows about the net? Yeah, please describe who knows the netting. Please tell me your name. Kiran. Kiran Kumar. Are you from Chennai? Kiran, not only the private to public or public to private, even private to private also, and public to public also, we can, convert the IPs. Okay. Anyone else? Okay. No worries, guys. I'm going to explain what is the netting and how actually it works. Okay. And which netting the FortiGate is supposed, which netting ASA support, sorry, ASA support, and which netting the Palo Alto is supporting. Okay, I will describe each and everything. So, network address translation, a service which enable us to map one IP address with another IP address. It may be the public IP or it may be the private IP. Okay, net, a feature which enable private IP address to communicate with the public IP address or vice versa. Means public also can also communicate with the private, even private also can also communicate with the public. Okay, clear guys? How it is going to be communicate? Let me explain you. I will explain you on this. Okay, or later what it is telling net. uh, when we talk about IP address style, we have a three type of IP address, right? Unicast, multicast, and broadcast. Unicast means one to one. Yeah, Pankaj, please mute yourself. Okay. If any question, you just raise a hand or you unmute and ask me the question. I will give the answer. Okay. No need to worry. Unicast means one to one. Multicast means one to many, and broadcast means one to all. Right? Correct, guys. Okay. Okay. Now we're talking about but net. But when we talk about IP address, there is a two type of IP address, especially public IP and private IP. Correct? So in public IP address are those address which are easily accessible via internet and they are unique in the world, right? I can access any public IP in the world, whatever it is in running now. I can ping it, right? If the ping is allowed, I can able to ping the any public IP like 1.1.1 based on the range. You guys knows about the ranges of IPs, right? Public private IP address range and the public IP, right? Yeah, what is the like 10 class A, class A, class N, class B, and class C? Especially we are having, safely we are having like private IP address range, and let rest are on the public IP address. Okay, the public IP address we need to purchase, and the private IP we don't need to purchase. Okay, but public IP I can easily reach to the public network, but with the private IP I can't reach to the public network like Google.com or anything I can't access, right? For internal communication we are using the private range, right? Okay, remember this. Internet contains only public IP address. Private IP address are those address which can be used for, you guys knows about, so I'm not going to describe on this. Okay, private IP address. Why net is required? Now assume that a company is having a private IP address in their lane. Obviously, in the lane, company will use on the private IP only, and the lane want to communicate with the internet. How? How you going to describe that? Anyone? How we are going to is communicate with the public network with the by using a private network? So let's suppose like okay, let's suppose I'm just going to draw some things. Okay, some diagram I'm going to draw. So no, we'll come one by one. Okay, now talking about the entire net. So let's suppose we are having one user. Okay, we are having one user with the IP address 192.168 dot uh, 101 dot 100. Okay, this is our user which is connected with R1 means router. Okay, the router IP is 192.168 and 19.1. I'm just using as a 19.1. I'm giving. Okay, or I will give 101.101.1. I'm giving here. Okay, this is their IP. Now the router is connected with the internet. Okay, public network. So in this interface, we required one public IP 101.1.1.100, and here you can assume 100.1. Okay, later the public network. Okay, we are having, let's suppose this is a Google server. Okay, this is our Google server with the IP 8.8.8.8. Okay, so how we are going to be let's suppose this is the private IP user, and this private user wanted to access the google.com. So request will reach or not to the public? Just tell me now. With private IP without netting, with private IP, it is possible to reach here private to public? No, right? So for that we required a netting, right? So how the source IP will be, like how the packet will generate? So source IP will be 192.168.101.100, right? And the destination IP will be 8.8.8.8, correct? Correct. Now the packet is going to reach to whom? To router, right? Correct now. So now it is reaching to the internet. Okay, and internet is reaching to the destination. Now the destination will generate one packet. Okay, 8.8.8.8. Now source IP will be 8.8 because it is replying, right? Correct now. Now it is a reply. So 8.8 and the destination. Just a minute, someone want to join. Okay, so Just a minute, guys. Where I was. Now, now the source IP we knows about 8.8 at the reply time, and the destination will be 192 168 right? This the firewall will check. Okay, this server will reply to the internet. This is server, and server will replying with this IP. Okay, internet will check. Okay, coming from 8.8.8.8, that's fine. Going where you want to go, this 192.168.101.100. So this internet will reply on this. Server is replying to this internet. Okay, but is it possible that internet will also allow to go that packet is the internet will allow the private network? No, right? Because where is what is the destination 192.168.101.100, right? So this is a private IP, correct? So internet will check this is a private destination, is a private IP. I need to drop the packet. The packet will drop. With overall, what I want to tell you, with private IP you can reach to the internet, but you can't get the reply. Okay, don't think like how can I reach to the Google or somewhere else with the private IP. You can reach without netting also, but the thing is you can't get the reply from that internet. Internet will send your packet to the destination, but destination at the time of reply, this internet will check. Okay, that is what is the destination. The destination is the private IP you are getting. Just drop a packet. Okay, clear, guys? So that is the reason we required a netting. Okay, fine. Okay, so lane will generate a packet with private source and public destination. What it is trying to say? Lane will generate a packet with private source and the public destination. Packet will go to till the destination, but reserve. Okay, means there is something missing. Like reply will not come. Okay, reply will not come. Packet will not come to solve this problem. Packet will not come overall. Reply will not come means packet will not come. To solve this problem only we are using the net. Okay, now clear? Okay. Type of net. What are the type of net? How many types of netting? Static net, dynamic net, pait, static, pait, and guys, net, dynamic, pait, net, right? So here I would like to bring something in the picture. Static net, like many manufacturer like Cisco, Palo Alto, and FortiGate. If you talk about this Cisco ASA, if you talk about the Palo Alto, if you talk about the FortiGate, static net will work will the support by the ASA and the Palo Alto. Dynamic net is also supporting by dynamic net also supporting by ASA and the Palo Alto. That static net is also supported by the FortiGate, but dynamic net is not supporting by this FortiGate. Okay, PET will support by ASA. Static PET or destination net is also supporting by the ASA, but this both will support all this netting type, but the firewall FortiGate firewall will not support this dynamic net. Okay, here guys, said you clear? No, this is because I will tell you when we are talking about the dynamic net, I will explain how the packet is going to generate for the static net, dynamic, and a pet. Okay, so you will be clear because it is not in use actually. Okay, this is useless actually dynamic net. Okay, na? So the pet is going to be used, but this is not my mistake. Okay, this is mistake by development. They are not supporting means I can't do anything, right? Clear, guys? Okay, so static net. In static net, we create one-to-one mapping of IP address. Means one-to-one mapping means one to one means one private IP with the one public IP. Correct? Let's suppose this is user. This is your user. This is your user with the IP address like 192.168.101.100. Again, I'm taking the same example and connected with one firewall. Okay, firewall IP is 101.1, 101.1. Okay, here 101, 101.100. So here 101.1 I am giving. Okay, and connected with the FortiGate firewall, and the FortiGate firewall is connected with the internet, and the internet is connected with the one server like Google. That IP is 8.8.8.8. This is a Google. Okay, okay. So now, sir, what will be the source IP? Source will be this one only, 192.168.101.100, right? And the destination IP will be 8.8.8.8. Means this user want to communicate with this one, okay, this server. So source will be obviously here, right? And destination IP will be obviously here 8.8.8. Correct? Correct now? Here, guys. Now the request is coming to internet. Okay, the firewall is send it to the internet here. How packet will be like this? Okay, like 101. So the packet will the new packet will generate here. Okay, source ip will be 101 dot how. Okay, 101 dot this is our sorry, I forgot to mention the public IP here. So 101 101 dot 1.1.100. I'm just keeping 1.1.100. Okay, here in the 1.1 I'm keeping here 1.1. Okay, now I'm talking about here 1.1. Okay, anything IP I can keep here, not an issue. So the request will come to the internet by using which IP? This 101. Okay, 101.1.100.101. By using this IP. Okay, it will reach and the packet will generate like, the packet will be like 101.1 dot, where it is when 101.1.1 dot, no, 101. Okay, the destination will be 8.8.8.8. Now the packet is generated and the packet will send to the internet will send to the server. Now at the time of reply, okay, no, not only this will come like this, and in the same time source IP will be 8.8.8, and the destination will be this one 101. Okay, 101 IP will be the destination IP, and the packet will generate like this, and it will come to the internet will come again to the firewall, and the firewall will be, here I can say like, one, this is a private network, this side is your private network, and this side your public network, right? This from here to here your public network, from here to there it is private network, correct? So we can say private to public and public to private. Okay, clear? So by using the single IP only, this 101.1.100 or one this interface IP only, the packet will generate and the packet will send to the destination, and the destination will reply with the their source IP, and the destination IP will be our single interface IP, and the packet will come to the firewall, and after firewall to the user. This kind of scenario will be happen in the static net. Okay, in a static net we create one-to-one mapping of IP addresses. Here, guys, for one particular IP. Let's suppose there is a multiple user. Okay, like there is a multiple user. Sorry. Like this is a PC. This is a user one. Okay, this is user one. This is user two, and this is user three. Like this is an IP with the 192.168.192.168.1.1. Okay, dot 1.1. Just assume that 192.168.1.1. Here 192.168.1.2. Here 192.168.1.3. Okay, this is a private network, private area network. For this particular user I required here, this is our FortiGate firewall, this is our internet. Okay, so for this particular IP I required one public IP. For this for user, this I required one public IP. For this user means every private IP required one public IP. Okay, so that is not going to be worthless. Dynamic net, it is not going to be supported by this FortiGate. So that's not good to discuss about this dynamic net. Okay, so dynamic net generally we is the same concept, and the single IP will be multiple private IP will be covered with that this IP. Okay, so dynamic net is not going to be used. Pet means a pet. In a pet we map multiple IP address to a single IP address using pet. We can map about 65,000 IP address to a single IP. Single IP means single public IP. Okay, address, it is unique, unidirectional. Okay, it is in unidirectional and bidirectional. पता है ना? Do you know, guys? Unidirectional and bidirectional. Like, just going to explain here by using the diagram. Yeah, I'm just going to brief it. Like, I'm just going to brief it. Be online. Here, I will explain. I will explain you with this. Okay. Let me change the color. Yeah, it is. It is little bit better than that, right? So here, let's suppose this is a user, and this is connected with the one router. Okay, and that after router we are having a internet, and internet to this internet only. Keep it like this. Later we 8.8.8 anything we can keep. Okay, so after that it will come like 65,500 means only single IP I'm using here, like 1.1.1.1, right? And I'm having a multiple private IP. Okay, inside of network I'm having multiple private IP. So instead of providing a single IP for the her particular IP private addresses, so better to I'm using one public IP, and based on the port number, port address translation range is a 65,000, right? Well known port, right? So well known port around 1,000 you can minus here. Okay, so 64,000 kind of connection you can create at the same time by using a PAT. Like 64,000 private IP can convert their self into the public network. Okay, by using the port. Let's suppose there is one user. Okay, one user IP is 192.168 dot 10.1. Okay, I'm using one IP 1.1.1.1. Another user 20.1, 10.1, 20.1, or 20.3, 20.4, 20.5. Like this I'm having a private range. Okay, these are my private area, and the public address for the all will be used by 1.1.1, 1.1.1.1, 1.1.1.1, still 64,000, because well known is a minus. We are going to do 1,000, around 1,024 there is right, but I'm just minusing 1,000 uh, port. So we are having a 64,000 kind of private address will be communicate by using the single IP address. Okay, but how this will work with a single IP is capable to convert our request into the public network? Is it questionable, right? You anyone? It is coming in your mind by using the port number. If it is not, I'm just going to explain you. This IP will convert by with this IP. Okay, this private IP will convert by this 1.1.1, and then the last they will add some port number like 40, like 80, like 10, like 20, like 22. This kind of port they are going to be used after the IP. Okay, so that is the reason we can communicate by using single IP with the Google. At the same time, we can create a 64,000 connection. Clear, guys? If you don't know, I, I will. I am just going to say. I'm just going to share my one of real time network, real time firewall. Just a minute. Be online. This is my real time firewall. It is running in the to someone in with my client. Okay. So here, look, status, network, everything is there. I will explain you one by one. DNS, okay, interface. Here in interface, we are using the particular interfaces, okay, like Airtel or some act I'm using, okay. So which IP here, if you see where it is, DNS in static route 192.168. Yeah, so I'm having one single IP here, right? 124. This IP only I am assigning to the interface, right? So lane to N, if I talk about the lane to N policy, here if you find, you will get the net. Okay, use a dynamic IP pool that I will discuss later. Use outgoing interface address. Whatever the interface IP you're using in the the public IP, whatever you're using into the interface, that IP will help you to send out your request to the Google, and you'll get the reply by using the same public IP. Okay, clear, guys? Is it clear? Okay. So can we anyone else to describe anything? Hello. Someone is asked me to describe in depth, like Manoj, you asked me only, or Manoj or Kiran you asked, right? So is clear, guys? Okay, great. So now, okay, static pet. Now, what is the static pet? Let's suppose you are having some firewall in not the firewall. There is a server. Okay, that is your web server. Okay, the web server is running with the AT, like HTTP service you are using here. Okay, in this server. Okay, in the same time you are having this both are connected with the firewall, and the firewall is connected with the another server. Okay, this is also the server. This is also server with the port number 443. 443, what is the port number? Like which service is using 443 port? HTTPS, correct. So HTTPS. Okay, and let's suppose this is the internet. Okay, the internet, here I am using one IP 1.1.1.1. Okay, if someone is this outside public user, this is a user, like an outside user, someone is there, someone seated in the laptop. Let me try to draw someone. Okay, my drawing is not good. So this user is wanted to hit this, this public IP by using 1.1.1.1 colon 80. Okay, the request will come where? To the your firewall will check where the request is come from. Okay, outside. The what is the IP? Source IP, let's suppose 8.8.8.8, and the destination will be here IP. The IP I'm using here 192.168.10.1. Here I'm using 10.2. Okay, 10.2. The destination will be 192.168.10.1 with the port number, source port, and sorry, destination port will be 80. So the request will come to the firewall, and firewall will check the port number. Based on the port number, it will it will send request to the this server. If someone wanted to communicate with in the same IP, like 10.2, with the same public IP, by using this public IP only, if someone want some other user in the outside, they want to communicate or access this server. So what will be the IP? Let's suppose that in the IP will be 192.168.11.1. I'm using this PC. He is like us. Okay, outside user. So this will be a source IP. The destination IP will be hit to this one only, 1.1.1, 1.1.1.1, and the destination port number is a 443, means HTTPS service. Packet will generate, packet will send to the internet will send to this public IP, and public IP is connected with the firewall, and the firewall will check the request is coming from somewhere else. That's what is the source IP. It will check what is the destination IP. Okay, 1.1.1 hitted me. Okay, hitted me with the which port number? 443. Okay, send this packet to this server. It will not send to this server because coming with 443, and this server is, I'm just hosting this server by using 443. Correct? Clear, guys? Yeah. So this is our static pet. Okay. Clear, everyone?